Hello, everyone. I'm super excited to be a part of the second GraphQL conference. I hope you're all having fun and enjoying the coffee. Before we start, let me introduce myself. I'm Denis from the Guild. I'm also a member of the GraphQL TSC group. So feel free to chase me down and smother me with any GraphQL-related questions. I'll be very happy to answer many of them. So let's jump right in. What is federated GraphQL and why is it important? Federated GraphQL allows us to break down a large monolithic API into multiple smaller services, which we call subgraphs. And each service owns its own part of the schema. So for example, a user service might manage user profiles while a product service handles product data. Despite this separation, clients interact with a single GraphQL API. And this means that even though the schema is split across services, the client only sees one unified API. They don't need to worry about which service is responsible for what. All of the magic happens behind the scenes where services can reference each other's types and fields. GraphQL Gateway is what does most of the heavy lifting. So the gateway sits in front of all of the services and is responsible for compiling the query, breaking it down into smaller requests for each of the subgraphs, and then stitching the results back together. The benefits of this approach is significant. So first, it allows us to scale services independently, which is crucial for large-scale systems. Each team can develop and deploy their service also autonomously and independently. And domain-driven designs fit naturally within the structure because each service is only responsible for its own specific domain. So in essence, federated GraphQL gives us the power of distributed system with the simplicity of a single unified GraphQL interface. So there are two leading federation specifications that standardize how a federated GraphQL system works. One is the Apollo Federation spec, and the other one, the upcoming GraphQL Composite schema spec. Let's start by briefly talking about both. So Apollo Federation allows us to create subgraphs where each service manages its own part of the schema. These subgraphs are then composed from a unified, providing clear boundaries for each of the services. Apollo Federation uses a set of key directives like add key, add extends, add provides, add requires, and these manage how types and fields are shared or extended across services so that each of the subgraphs can also communicate between each other. So they make it possible to resolve cross-service references and establish relationships between entities. Subgraphs can evolve independently, so each service is responsible for its own schema and changes, such as adding new fields or new types without affecting the other services, as long as the directives and the relationships rules are respected in the Apollo Federation spec. The other player in the field, rather new one, is the GraphQL Composite schema specification. It's the official work backed by the GraphQL Foundation. The specification allows us to create a single unified schema by merging multiple source schemas from different services. The unified schema, or the composite schema, appears to the clients just like a regular GraphQL schema. The specification is built on several key design principles that make it highly adaptable and effective for large-scale systems. So first, it's composable. And instead of building each source schema in isolation and trying to fit them together later in the composition step, this approach encourages us to design source schemas as part of a larger system from the start. Services can therefore easily reference and extend each other, creating a cohesive schema from the get-go. It's collaborative. It's designed specifically with teamwork in mind. Multiple teams contribute to the overall schema. Any potential conflicts or inconsistencies are caught early during the development. This ensures smooth collaboration without the risk of one team breaking the entire system, compared to Apollo Federation, where each of the subgraphs is built in isolation, and they just have to follow the specification rules without worrying about what other subgraphs are doing. It's also evolvable. As our underlying services evolve, the composite schema approach allows us to shift functionality between services while keeping the same API interface for the clients. In other words, clients continue to see the same API even if the backend service changes. It's very explicit. So one of the core ideas in the GraphQL Composite schema is to be clear and as explicit as possible. It avoids ambiguous assumptions and conventions. We'd reduce the risks of failures as the system grows and becomes more complex. In practice, the GraphQL Composite schema spec is built around two key components, just like Apollo Federation. The schema composition, so this is where the source schemas are merged into a single composite schema, and the distributed execution. The executor handles the core logic and algorithms for resolving requests made against the composite schema. It coordinates how data is retrieved from the various underlying services, making sure everything runs smoothly across the distributed system. This spec enables us to build a highly scalable, flexible, and future-proof API that can evolve with our services without disrupting the client experience. So we've been introduced with the two federated GraphQL specs. Let's talk about the actual brains of the system, the query planner and the executor. How do they actually work? Can we have an executor that universally can cover all possible federation specs, not these two, but potentially future ones? And finally, is a spec agnostic query planner and executor even possible? So let's see. The workings of the query planner and execution boil down to 4 steps. The first one is query planning. In this step, the query planner receives a query from the client and breaks it down into subqueries based on the schema owned by each of the subgraphs, and then identifies which subgraph needs to resolve specific parts of the query by looking at the type, ownership, and relations. And finally, a query plan is generated, defining the order and dependencies for fetching the data from the various subgraphs. Then the next step is the actual subquery execution, where each subquery is dispatched to the relevant subgraph, where it is resolved independently. And then the executor manages the parallel and sequential execution of these subqueries, keeping the data dependencies between those subgraphs in mind. Then it does result merging. So once all of those subqueries have been resolved, the gateway merges the responses based on the query plan. And the final result is then stitched together and sent back to the client as a single unified response. The fourth step are optimizations, where the executor optimizes the performance by reducing service-to-service calls, executing non-dependent subqueries in parallel, and fetching data in batches where possible. Also, it's possible to reevaluate the plans that have been made and further optimize on subsequent requests. So both specs that I've talked previously about share the same idea, and the mechanism for fetching data is also almost the same. So creating a specless query planner and executor might just be possible. So introducing GraphQL Composite. This is a spec-agnostic GraphQL Composite schema planner, executor, and explainer. But I have to say that the library is being actively developed and is not published anywhere as of right now. You can visit the repository by scanning the QR. You can dig through the tests and the fixtures to get an idea of how this all works. But it's very experimental and is missing a lot of things. So the work on the library itself started because I wanted to learn and get in-depth knowledge about federated GraphQL. Why are query planners and executors so complicated? How do they work, and what decisions do they have to make in various scenarios? What about edge cases and all the possible things that can happen and weird queries that the client might send? And I can tell you something, federation is hard, especially federating interfaces and unions. Those things are a completely different story. Arda knows. Being zero-dep means that you don't need to worry about external packages or libraries. It's lightweight, it's highly portable, and easier to integrate into any environment. So you can run it on the edge, you can run it on your Docker instance, you can run it natively on your node. Oh, and because of this, it aims to be very secure. The library is not tied to any spec, any GraphQL Federation spec, and that includes Apollo Federation and the composite schema spec that I talked previously about. It aims to support all existing federated specifications. In fact, you can even design your own blueprint. I'll explain what a blueprint is in a moment, on top of your existing non-federated GraphQL sources for query planning and execution, making it highly adaptable and future-proof. The planner produces stable, predictable execution plans that come with detailed execution explanations. This transparency makes it easier to debug, optimize, and understand how queries are resolved and how the final result is assembled. All steps leading up to the execution are serializable, which means that they can be cached at any point during the planning process. This allows for efficient reuse of query plans and significantly improves performance by skipping redundant planning stages. Combining the serializability with persisted operations, you can get a very performant and highly secure GraphQL API. Make sure to attend Benji's talk tomorrow about techniques of protecting your GraphQL API and learn more about persisted operations. You will then potentially understand how caching a query plan together with persisted operations will give you a performance boost. Finally, the library is being developed using test-driven development and leveraging the Guild's Apollo Federation audit to ensure consistent and reliable progress, giving confidence in its stability and correctness from the very beginning. Of course, it doesn't yet pass many of the tests, but we're slowly getting there. So let's go over a high-level overview of how GraphQL Composite works. The first step is to create a so-called blueprint. It's sort of what Supergraph is to Apollo Federation. It contains the relationship information of the subgraphs and how they form a composite schema. At the moment, blueprints are created manually, but in the future, GraphQL Composite will be able to translate any federation spec, Supergraph, or the composite schema to the native blueprint. After that, a gather plan is created for an incoming GraphQL query. The gather plan is the query plan, actually, explaining what and how to fetch from where of the subgraphs available in the system. And of course, how to assemble those results. Final step is executing that gather plan. So we understand things best through practical implications, so let's go through one. Let's say we're building a federated system with 3 subgraphs. A store subgraphs containing information about the stock and product identifiers. As you can see, it's like a very, very simple SDL. Then we have a product subgraph containing detailed product information and very basic manufacturer identifiers. And finally, a manufacturer subgraph containing only details about the manufacturers themselves. No products and no other relations there. Notice how each of those subgraphs were just regular GraphQL endpoints. They don't have any federation-related trickery. No special directives, no special fields. Think of the subgraphs as regular GraphQL endpoints, which are not meant to be federated. Our task now is to assemble a blueprint which will communicate the subgraph contents and their relationships. This is what we want. This is the resulting schema that we want to expose to the user. I hope it's not cut off. Yeah, it ends well. So let's get started. First of all, is this better? No? Yes? No? Yes? Yeah, I'll do the light theme then, sorry. The blueprint is very similar to the GraphQL SDL. You define types and fields, but in addition, you need to define the availability across subgraphs. Like with the GraphQL SDL, you start by defining the query type. So here, you see that you define a query of an object kind, which is query, and then you define the fields. You define the name of the fields and at which subgraphs those fields are available and what are the types in each of those subgraphs. Then you would define resolvers, which
then you would define resolvers, and in those resolvers, you would specify which subgraphs and how do they resolve this specific type, as well as the variables that you need to provide to that resolver in order to get that result back. So this is just the part of the query. Then we proceed and we continue with the one moment. And then we continue with the store type. Here at the store type, it's kind of similar. So you define again a store object that contains fields and that where those fields are available. But there are no resolvers here because we don't need any. Moving on, we define the product. Here the product is also the same, but notice how the product's ID is available in multiple subgraphs. So the products and the store subgraphs, and the ID type is the same for both of those. And everything else is the same pretty much, only available at specific subgraphs. The reason why this ID is available and why you define the availability into multiple subgraphs is to tell GraphQL Composite where you can use this ID from and how to resolve if you are coming from one of those subgraphs. Finally, you would define a resolver for a type. So here we are defining a resolver for the product type on the product subgraph. And we say that we need a product ID to query the product by that ID. And the variable is that product ID that gets selected from the ID of the product. So if in the part of the query you have the ID of the product, it will be used to fetch the product from the product's resolver, from the product subgraph, sorry. And then finally, we define the manufacturer, which is the simplest of them all. You may notice that here, again, the ID is available in multiple positions in the subgraphs, both manufacturers and the products. The name is only available in the manufacturers, while the products are only available on the products subgraph. So you can see how the different relations of the schema, basically of the subgraphs, allow us to combine the data into a single GraphQL endpoint, just by defining where each of the fields and each of the types are available and defining the resolvers necessary for querying them. So here, like we explained with the product resolvers, the manufacturers can be resolved from the manufacturer's endpoint, and this is the query that you would use to fetch it. We use a built-in export fragment, which will later on be populated with the actual fields that are necessary for performing the query. And that's it. So we have, one moment. So easy as that. The blueprint is now ready. It's basically a big object containing all of the blueprint types that we just went through. And you can scan the QR code to actually see it in code and how it looks in the code. So if we scroll through this, it is basically each of those types defined as it was in the previous slides in one big object. So you can see how easy it is to assemble a blueprint and then combine sources and subgraphs to one unified subgraph, one unified endpoint, sorry. And these primitives work for Apollo Federation as well. So places where you would define resolvers in a very simple manner here, you would also define for Federation. And if you have opened the repository and went into the Federation part of the fixtures, you can see how Apollo Federation system can also be resolved using GraphQL Composite. So okay, now having built the blueprint, we're ready to execute queries. Let's take this one, for example, a single query that reaches all of the subgraphs and lets us break down to understand better what's happening under the hood. So the first step is actually fetching the store from the stores subgraph. So this part of the query that is highlighted here. it's a bit weird, is this query that will go to the stores subgraph. And then the next step is that for each of the product IDs fetched from the store subgraphs are used to query the product subgraph and retrieve the product's information as well as the basic manufacturer information about each of that. So you can see here that the product ID from the original query will be used once resolved as a variable to the product's subgraph containing information about these specific fields that are highlighted. Then the third step is also for each of the manufacturer IDs fetched from the product subgraph, we query the manufacturer's subgraph to retrieve the manufacturer's name. Because if you remember correctly, the manufacturer's subgraph only contains the name for the manufacturer. And here we inject a private ID field which is not exposed to the user but is added by GraphQL Composite in order to be able to perform the manufacturer's subgraph query. And we're done. That looked simple enough. Well, conceptually, yeah, but actually building the code is a completely different story. So this gather plan you're looking is fully serializable, and you can cache it and avoid planning it again. Ideally, you would store the gather plan alongside your persisted operations and only have the executor running on your production environment. So having mentioned execution, let's dwell into that. Oh, and if you scan this QR code, you will actually see the snapshot of an actual test where we perform this exact query inside the GraphQL Composite repository. So the execution is very simple. It's all about following the rules of the gather plan. Having the plan very explicit, the execution part itself can be isolated and modularized so that you can have only the executor running on Edge, for example, or you can implement the executor in another language and squeeze out that max performance. It's very important for an executor to explain what has happened in as much detail as possible. So explaining the execution helps debug issues if some subgraphs turn out to be unavailable or if you're unsure about the decisions the gather plan has made. But not only that, you can also gain additional insights like metrics and costs of each of the fields being resolved. Again, the full explanation is like this. So this explained here is actually a real query being made against subgraphs. As you can see, it's pretty extensive and huge, but it is quite simple to understand just by reading it. Scanning the QR code, you can get exactly this snapshot, maybe not formatted really well, but the idea is there. It's missing also a lot of additional features like metrics and costs that I already have explained, but ideally I would want to have the whole library accept plugins, which will then extend these explanations with further information. So let's see those tests passing. I made an actual test here, which, yep. So here on GraphQL Composite, on the conf branch, which is not there, conf, there it is. I have made inside the tests and inside fixtures, sorry, it's hard to see from this side. I made an example here where we performed this query, the exact one that we have, that I've shared, and the expected result from that query. You can also see how the subgraphs are assembled. So there are a few convenience wrappers just for testing reasons which help create the subgraphs, but they are exactly as we have presented them in the presentation. We would have the stores subgraph, then we would have the product subgraph, and then finally the manufacturer's subgraph each containing its own information. So if I manage to take my terminal and put it on that screen instead, yep. And then we, damn, extending displays is always hard. So if I go back, yes, sirs. So now we are on the GraphQL Conf branch, and if we test exactly that, GraphQL is always hard to type. GraphQL Conf 2024. You can see that the tests pass, and those tests are pretty much exactly the query that I have showcased here in the queries area. So the expected result is the one that we want, assembled in order and fetched from all of the different subgraphs recursively. Some operations are performed in parallel, some are performed in series because you need the previous one to resolve, and you basically get the final result. I won't share the full explanation and also the gather plan. You can use the QR codes to see them in full shine, but they are too long to explain right now, so I'll just avoid them conveniently. Yes, I have to emphasize that the library is very work in progress. It's under active construction, and there are many missing features. Features like batching, subscriptions, or the deferred directive. But the work is being put on, and thanks to the Federation audit that was recently introduced, we are creating and making confident steps towards a completely and fully Federation-compliant query planner and executor. Thank you for your attention, and I will be happy to answer your questions. Yes?
Oh, hi. Thanks
Hi.
for the presentation. Really love the idea of the gather plan. It makes it very simple. Any idea of maybe like some way of visualizing the gather plan, like using some kind of charts just to show how the system
Oh yeah, definitely. So the question is whether visualizing the gather plan is on the plan, on the map. It definitely is. There's even an issue opened exactly like that, where you would want to have a pretty view or have a view similar to Apollo's explanation, because people might have been used to it. So there are plans on doing that. But currently there are many core features missing, so I plan on working on that down the road. Yes, yes. That's definitely what you can see in the gather plan already, but you would have to do some manipulation to get an overview like the one you want. Okay, so the question is, what's the difference with between like spec agnostic runtime and what we have here? The blueprint that you just saw, it's really not a specification. It's a set of instructions on how to assemble the subgraphs to give you a result. And the specs, on the other hand, the Apollo Federation spec as well as the composite group spec that they're working on, they focus on composition, and they focus on how, ideally in the future, how the execution would work as well. But there are no, I try to have the blueprint as stupid as possible, where you would define relations, but you wouldn't define the reasoning and how to fetch stuff from each of the subgraphs. It would make all of those decisions on its own. So you could envision sometime in the future a drag and drop editor where you just combine fields and get a blueprint just using logic. And yeah, that's why I took the spec out of the whole thing. The original idea was to just understand how execution and how query planning works, which is hard. But essentially, it boils down to the same thing for any spec that already exists or might come up.
So the goal is not just to have a query plan, a generic query plan spec, essentially.
The goal is not what? Excuse me?
The goal is to have a generic query planning spec?
Yes. So if this turns out well, it might even be a reference implementation for any other language of how you might want to achieve basically execution and query planning. But the split is the fact is that GraphQL Composite is very modular. Each of the steps can work in isolation. So you can have a unit working on planning, a unit working on execution, and you can basically get the bare minimum running where you need it and get like the sweet performance boosted from Edge, for example, or places like that.
Do you plan to publish the specification for blueprints and
specification. Do I plan to publish specification for the getter plans and the queries? So currently, I'm actively working on the code. So there's many moving parts. So I cannot say that it will happen anytime soon, because I want to have the core stable enough and then read through the code again and make a spec out of it. It would be a proven concept. If all of the federation compatibility checks pass and we are on 100%, then you can be confident saying that this code works well, and then you can make a spec out of it. Any more questions? Cool. Thank you for your time. Yeah.
Sorry, one last one. So I'm thinking about this use case about like you can actually have an existing GraphQL server without any kind of federation directives and build a blueprint around it.
Yes.
Would this be helpful in companies who want to gradually adopt federation?
Exactly. Exactly. So you can gradually federate your system, and the way the GraphQL Composite schema group is working is that they want to use GraphQL primitives and idiocracies to create subgraphs, and that's essentially what you would end up doing. So if you try and use your existing subgraphs to assemble a gateway on top of them, and then you realize that some subgraphs are missing queries for resolving identities, you would just add it and explain it in the future blueprint. So you would also gradually start to understand how a federated system works and what are the necessary. The errors are also helpful, so I try being very explicit in showing errors if something does not make sense. So gradually you could get to that point, yes. No more questions? Cool. Thank you for your time. You can find the presentation here as well.